Hi everybody. My name is Marissa and I have a bachelor's degree in mathematics with a minor in statistics. In today's lesson, I will be discussing how to compute the center, spread, and 5-number summary of a dataset. There are two types of data, qualitative and quantitative. Quantitative data is data that is numerical, such as height, weight, or number of siblings. Qualitative data is data that is non-numerical, such as hair color or whether or not someone owns a cat. Today we will be discussing quantitative data and how to summarize it. When analyzing quantitative data, it is common to begin by looking at the center, spread, and 5-number summary of a dataset. The center of a dataset describes the middle value or average value. The center of a dataset can be described either using the median or the mean. The mean, denoted by x bar, is computed by adding all numbers in our dataset and then dividing by the number of numbers we have. The formula for the mean is read as x bar equals the sum of x sub I divided by n. If we have the x values 1, 2, 3, 4, and 5, we would add them together and then divide by 5, giving us a value of 3. The median, denoted by m, is found by finding the middle number of a dataset after ordering our values from least to greatest. However, if there are two middle numbers, we add them together and then divide by 2. When our data has a mean and a median that are roughly equal, this is called symmetric data. If we have a dataset that contains very large values that increase the mean, we call this a right-skewed dataset, and the mean will be larger than the median. If we have a dataset with very small values that decrease the mean, we call this dataset left-skewed, and the mean will be smaller than the median. Values that are much larger or smaller than the rest of the data are called outliers. When our data contains outliers, it is best to use the median as our center, as the median is resistant to outliers. For example, let's say that we have the following ages of students in a statistics class: 19, 20, 20, 21, 22, and 75. Taking the mean of this dataset, it would appear that the average age of students in this class is 29.5, because one ambitious 75-year-old drove up the average age of the class. However, our median would only be 20.5, which is a better representation of the average age of the class. The spread of a dataset measures how much each value varies from one another. We can measure the spread of a dataset using the range and standard deviation. The range of a dataset is simply the largest observation minus the smallest observation. The formula for standard deviation is a bit more complicated and has two different formulas, one for population, denoted by sigma, and one for sample, denoted by S. The formula for population standard deviation is sigma equals the square root of the sum of x sub I minus x bar squared divided by n. The formula for sample standard deviation is S equals the square root of the sum of x sub I minus x bar squared divided by n minus 1. Note that both the standard deviation and range are not resistant to outliers. Let's say that we want to compute the standard deviation and range of our previous statistics class. To compute the range, we would simply subtract the youngest age of 19 from the oldest age of 75, giving us a value of 56. To compute the standard deviation, we will use the formula for population standard deviation because we were looking at data from an entire class, the population. We know the mean is 29.5 from our previous calculation. Now we must subtract the mean from each x value and then square them. We then add all these values together and divide by 6, our population size. We then take the square root of that result and obtain a standard deviation of 20.37. The 5-number summary of a dataset contains 5 values: min, Q1, Q2, Q3, and max. Our min is our minimum value, or simply the smallest value in the dataset. Using the data from the statistics class example, we obtain a value of 19 for our min. Q1 is our median for our lower half of our data. We split up our data before and after the median, or if there are 2 medians, the smaller median is included in Q1. We then find the median to obtain a value of 20. Q2 is our median, which we calculated previously to be 20.5. Next, our Q3 is calculated by finding the median of the upper half of our data and then including the higher median in that dataset if we have 2 medians. This gives us a value of 22. Lastly, our max is the highest value in the dataset, which would be 75. A common mistake that students can make when computing numerical summaries of quantitative variables is forgetting to include the lower median and the upper median in Q1 and Q3 respectively. To avoid this mistake, we must ask ourselves if we have 1 or 2 medians. If we have 1 median, simply divide the data into upper and lower halves before and after the median, exclusive. However, if there are 2 middle values, then include the small value in Q1 and the large value in Q2. Let's test our knowledge on numerical summaries of quantitative variables by doing a quick exercise. What measure of center should be used for the following dataset? Please explain. X equals 60, 61, 62, 63, 64, and 84. Begin by computing both the median and the mean. If they are roughly equal, our data is symmetric and we can use the mean. However, if the mean and median are significantly different, we must use the median. Using our methods for finding the mean and the median, we obtain the values of 65.67 for our mean and 62.5 for our median. These values are different enough that we should use the median to account for outliers. Great job, everyone! Today we learned how to compute the center and spread. We also learned how to compute a 5-number summary. Thanks for watching, and please be sure to check out other videos about statistics lessons and applications here on Chegg. Have a fantastic day, and I'll see you next time.